Welcome to another video from How the Universe Works. Now, you may be wondering why the camera is pointed not at my head, as it has been in previous videos, but at some paper. The answer to that is that some maths will happen that needs paper. I'm going to show you a rather awesome maths trick that it could be some mind-blowing going on. I'm going to show you that. I'm going to show you what you get if you add up all of the positive integers. If you start at 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, and keep going forever. What you get. You just use basic algebra to show this. Apparently doesn't actually work. You have to redefine equals or something. But it's pretty cool anyway. So as your first sum, call it S1. Say that is equal to 1 minus 1 plus 1 minus 1 plus 1 and so on forever. Right? Now, what this equals depends on where you stop it. I mean, if you stop it here, it equals 1. If you stop it here, it's 0, 1, 0, 1. But if you keep going forever, well, where do you stop it? We'll see what this equals. So do 1 minus S1 equals. So that's 1 minus 1 minus 1 plus 1 minus 1 plus 1. That equals 1 minus 1 plus 1 minus 1 and so on. And that is the same as S1. So what we've got here, 1 minus S1 equals S1. You could here just think, okay, what number you get? 1 minus. If you subtract it from 1, you get that number. And say that it's a half. Or you could, if you don't trust that, actually work it out. So you say, you add S1 to both sides. 1 equals 2S1. Therefore, S1 equals a half. It's easy enough. If you do that and keep going forever, you get a half. It neither stops at 1 nor at 0, but halfway in between. Seems reasonable if you use common sense. Second sum we'll be using, we'd call it S2. That is 1 minus 2 plus 3 minus 4 and so on. 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on forever. Now what happens now is you add this to itself. So you get 2S2 equals 1 minus 2 plus 3 minus 4. And then what you do now, writing it out, you move it along 1. So you get plus 1 minus 2 plus 3 minus 4, and so on. Right? And equals, right? So you go 1 minus 2 plus 1 is minus 1 plus 1 minus 1. You see where this is going? We've got back to S1. And that is a half. So 2 times that is a half. What happens now is you subtract it from S. Hang on, I haven't said what S is yet. S. Now, S is the actual sum we're doing. 1 plus 2 plus 3 plus 4 plus 5. Forever. So you subtract S2 from S. S minus S2 equals 1 plus 2 plus 3 plus 4 plus 5 minus 1 minus 2 plus 3 minus 4 plus 5. Now that is now 1 minus 1 is 0. 2 minus minus 2 is 4. 3 minus 3 is 0. 4 minus minus 4 is 8. 5 minus 5 is 0. 6 minus minus 6 is 12. Just getting the 4 times table coming out here, see? So what we do now is you take out a factor of 4. Equals 4, 1. Plus 2, plus 3, plus 4, 4s. Go up here now. S minus S2 equals 4s. Now, 2s2 equals a half, therefore S2 equals a quarter. Right? S minus a quarter equals 4s. What I can do now, subtract s from both sides. Minus a quarter equals 3s. Then divide by 3. This equals minus a 12th. Would appear to suggest there, using some basic maths, that the sum of all the positive integers is minus a 12th. Apparently, that's actually bollocks, because, well, use common sense. You keep going forever, this is a diverging series. You get to infinity. You say, well, you're asking a silly question, you're going to get a silly answer. You draw a graph of it. You sketch a graph of it. where on the x-axis you've got a value, you've got a numberth value, and there you've got, and on the y-axis, you've got the total up to that point. It's going to look something like that. It's tending towards infinity. As x approaches infinity, y does. It can't. You keep going forever, you get infinity. So y minus a 12th? Well, there is a link between the numbers. You see, you then, because this graph, you're plotting the formula. You're plotting the function what y equals half n n plus 1, right? Where n is the number of values you've had so far, and y is the total up to that point. This is the n-axis and the y-axis. Call it s, actually. So then you can include the negative values in that, and you get something that looks like that. And the area here, that is, if you integrate that and do maths on it, you can get the area there is minus a 12th. That's the connection. The area here and here is infinite, right? That is minus a 12th. That's where that's coming from. I'm not entirely sure how it gets into there, how that makes it the answer to this sum, but it does. Maths, you know, I don't know maths. Except some of it. But there is some complicated maths and physics that I don't quite understand. That means that this is why there are 26 dimensions in string theory. Because the sum of all the positive integers looks like it's minus a 12th. But it doesn't actually, because it just doesn't. Because that would be really silly. I mean, even if it's finite, you expect something like 1 or 0 or pi or something. But minus a 12th. It's got everything equal to negative fraction. Well, it doesn't, that's why. It's like Berwick-upon-Tweed isn't in the Crimean War. Or it isn't illegal to die in the Houses of Parliament. Thomas Huxley remarked that one of the great tragedies of science is the slaying of a beautiful hypothesis by an ugly fact. Here we've got our beautiful hypothesis that the sum of all the positive integers is minus a 12th, and the ugly fact that it isn't, because that's not what it actually is. And with that, goodbye.